Let's begin with then today's lecture. Okay, and I am always telling you, please interact. Okay, now let's begin the today's lecture. Today we are going to study about the resistor. Actually, these are not so much important, but sometimes question are asked from here also that resistors are generally, resistors are just opposing element. They oppose the flow of current. Actually, they oppose the flow of current, and they are actually usually of two types. One is that is wired, or we say wound type. They are in form of wound. Like example, nichrome we see, which is used in a heating element in a heater. Nichrome, tungsten bulb. We have seen manganese or alloy, different alloys are there, manganese. These are all are one wound type resistors, and one is carbon type resistors. Carbon type resistors, and these carbon type resistors are very cheap, and they are designed to in a circuit, so that they are designed so that they are used in a circuit which makes the proper working of different elements, and they make a drop, and they work as a safety element for the other elements that we will see further. Now let's begin. Let's begin. When we are discussing about this carbon type resistor, these are the color coding which we are used in a carbon coding, color coding of a carbon type resistors. These are the colors. Okay, you can see these are the colors, and these are the digits, multipliers, and tolerance. For you these tolerance are not so important, but you should remember this tolerance, this one, this one, these three tolerance you should remember. And all the multipliers are just having the power same as this. You can see they are following the pattern. And one more thing, you must have remembered that in your class 12 also you must have studied one trick, that BB Roy, that I like that BB Roy, very good, like that. Great Britain here, like this. Great Britain, very good wife, like this. Okay, you must have studied like this, very good wife. Okay, wears jewelry of gold, silver, and nickel, like this. You must have studied to remember B for black, B for brown, and like that. Okay, now you must have studied. You should remember by using this technique. BB Roy, BB Roy, BB Roy, Great Britain, very good wife, wears jewelry of gold, silver, and nickel. Now, how do you use it? In your question sometimes is given that first some bands are given, first color, second color. You have to see by the first color, you have to decide the first digit, second band decides second digit, third one decides the multiplier, and fourth one tolerance. Let me take one example, then you will get clear. Suppose we are having one carbon type resistors like this. They are carbon type resistors. We are having different bands. Let us suppose we are having three bands. One is green, yellow, and it is brown. Okay, it is brown, and you have to write the resistance, value of resistance. What is the value of resistance? How to write it? We know how to write it. We know by using the technique. Green, first band and second band, will give you the digit. Okay, green. You see, this is G for green. Okay, see, green gives you 5. You can see it will give you 5. Second, yellow. You see here, yellow is 4. These first two bands gives the value of first two digit into. Third band gives you the multiplier value. Brown, see the brown here. Brown is, you can see 10 to the power 1. That means 10 to the power 1. Plus minus tolerance. Fourth one shows the tolerance. Tolerance, there is no tolerance, that is no color. No band means no color. That means tolerance for no color is, you can see 20%. That is, we can write plus minus 20%. By this way, you can write the any value of resistance of any carbon resistors. Okay, any problem here? Or I should take one more example. Any problem here? I think you must have studied in your class 11th also, 12th also. Any problem? Please be interactive. Any problem? Any problem? Okay. You can see this is the practically you must have seen this in electrical circuit. In electrical circuit, you must have seen like this. These are the carbon type resistors. This is first band, second band, third band, and this is gold tolerance. You can see first band brown, second black, third one brown, fourth one. You can write according to that. Okay, by seeing that table which I have discussed in the previous slide. Okay, let me take one example. You give the answer. I will move further. Let me take one example. There are four band. Let us give me one example. It is brown. It is brown. It is blue. Let me take it is gray. This one is yellow, and this one is silver. Can you please write the answer of it? Can you please, if in exam it comes, how will you decide this? In that, you must write like this. B.B. Roy, write like this. B.B. Roy, Great Britain, very good wife, wears jewelry of gold, silver, and no color. Decide, count from here. 0, 1, 2, 3, 4, 5, 6, 7, like this. Count like this. And from here, gold, silver, and no color. 5, 10, 20. Okay. You can see this only we have discussed here. You can see. Give me the answer, please. You have to follow this type of pattern whenever it comes in your exam. Write in rough. B.B. Roy, Great Britain, very good wife, yes, jewelry of gold, silver, white, and no color. After that, you can write the value. Any answer? I give, okay, answer given. Let me see. Okay. I think good. Let me see. Okay. I think for yellow, I think it should be 1, 5 into 10 to the power 4 plus it is silver. Okay, plus minus 10% like this. Okay. Okay now. Okay, you can see for yellow it is 10 to the power 4. Okay, by mistake you did 10 to the power 5. Okay. Let us move further. These are simple concept. You should remember this type of question. Okay, now very important Kirchhoff's, very important. Okay, let us see Kirchhoff's law, very important in current. Kirchhoff's first law. Kirchhoff's first law is also called as junction rule. It's also called as junction rule, or we call it as a point rule. Point rule. Okay, in short we write it like this, KCL, and say it as Kirchhoff's current law. Kirchhoff's current law. In this law, we relate current, so we say Kirchhoff's current law. It is telling that in any circuit, suppose we are having one network of conductors like this. Okay, one network of conductors like we are having different network of conductors like. Let me take 3 network of conductors. Suppose from here a current I1 is coming, and from here current I2 is coming. It is telling that at any node, at any junction, let us say junction. J. Junction means a point where more than 2 branches of a circuit meet. It is called as junction. You can see here at this point 3 branches are meeting, so it is a junction. At a junction, the sum of incoming current, here incoming current is equal to, we can say like that, either we say sum of incoming current is equal to outgoing current, Or we can say, suppose I1 coming, I2 coming, and I3 is going here. We can say like this. We can say I1 is coming positive, I2 is going, I2 is also coming to a junction positive, and you can see here I3 is going away from junction. So we can take it like minus I3 is equal to 0. So it is equal to I1 plus I2 is equal to I3. We can say like this also, sum of incoming current. This is what this is. This is sum of incoming current. You can see I1 and I2 is sum of incoming current, and I3 is outgoing current. So we can say Kirchhoff's law in two ways. Either we can say as Kirchhoff's law is algebraic sum of current at a junction. Algebraic means coming current, we can take it as a positive or negative, and outgoing current similarly in opposite direction. Okay, or we can say it like this, the sum of incoming current is equal to sum of outgoing current. Okay, this is a simple case of Kirchhoff's current. Any problem here? Any problem? You can answer any problem in Kirchhoff's law. Okay, let me take one example. Okay, let me take one example. Suppose I1, suppose 2 ampere current is coming there, and 1 ampere current is going there, and 3 ampere is coming there. You have to find how much current is moving from here. You have to find I. Can you tell me the answer? Simple question I have given to you. Can you give me the answer? Any answer? Give me the answer. Give what will the value of I? What will be the value of I? Any answer? Any answer? Any answer? Any answer? Getting confused? Okay, let me see. 2 ampere coming here, that means 2 ampere from here and 2 ampere from here also. Okay, so for this part you can say it is negligible because 2 incoming, 2 outgoing, or you can take also here 1 ampere. You can write like this: total incoming current is 2 ampere, incoming current is 3 ampere, and outgoing current is 1 ampere and I and 2. You can write like this: 1 plus 2 plus I. I think you will get how much you are getting there. 2 ampere incoming, 3 ampere incoming. Okay, 2 and 3, and outgoing is 1 here, 2 here, and I here. That means I is equal to 2 ampere. How you got 4 ampere? How you got 4 ampere? Any problem? Any problem? Any calculation mistake I have done? Okay, let us move further then. Now we are moving towards Kirchhoff's second law. It is also very much important. You can see it is telling that suppose in a network of conductors, suppose I am taking one network like this. Let us suppose I am taking one network of conductors like this. Okay, there is one network of conductors I am taking here. It is telling that suppose it is R1, R2, and R3. It is telling that the algebraic sum of potential drop across the current element. Current element means R, resistance, maybe inductor, maybe capacitor, maybe cell, like this, any current element. So sum of all those potential difference in an algebraic manner in a closed loop. Remember, it should be a closed loop. Closed loop means the point from where we have started, we have to move in the loop and return to a same point. Then we'll say it's a closed loop. Either we can move like this also. We can move like this also. Go here, go there, here, and you can move like this also. But you have to return to a same point. Then it is called as closed loop. Okay. Across a closed loop, if we add all those potential difference, algebraic sum, it will always equal to 0. That means if we are saying that it is a V1, it is having V2, it is having V3, then we'll say in this loop, V1 plus V2 plus V3 will be equal to 0, like this. You will take algebraic sign and it will be 0. Okay. Any problem? I have taken just informative example. I will take some calculative example also. Any problem in understanding this law? I will take some example and you will get clear from it. Okay. Let me take one example then. Then I think you will be clear. Okay. Let me show you first one convention, one sign convention. It is not necessary to follow, but if you will follow, you will never get confused. Let us suppose it is having resistance R, and suppose current is flowing from here. Okay. Let me take. I think yes. Let me take current I is flowing from here. If I am telling current is I flowing from here, let me take it is this side V1. It is terminal is having A and B terminal. Here it is potential V1. Here it is potential VB. We can say by Ohm's law, VA minus VB, that is potential difference, is equal to I into R. You can tell like this, and we know potential of VA is equal to is greater than VB. So this is the potential drop. So we find potential drop by using this formula also, or this formula only. Now, what convention we will use? We will use whenever in a circuit current is flowing in this direction, okay, and we are moving in this direction, we will take as a potential difference is equal to how much? We will take it like this, minus IL. This convention we will use it. What is my convention? You can, no problem, you can use opposite convention also. I am showing you one convention and I will use this convention solving any question. Okay. What is my convention? If I am moving along the direction of current, I will take minus of potential difference. Okay. I repeat once more. If I am moving along the current, I will take minus of potential difference. Okay. Suppose R is here, current is flowing here, okay, and we are moving in this direction, okay. Then we will take potential difference is equal to I into R and sign theta as positive because they are moving opposite to direction of current. Okay. Okay. Now, one more example, one more convention I tell you. Suppose we are having a voltage. It is having voltage V. We are moving in this direction. So suppose we are moving in this direction. What is happening? It is happening that potential is increasing from negative low potential to high potential. So when we are moving from low potential to high potential, we will take it as positive V. And if suppose we are moving in this direction, then what we are doing? We are moving from high potential to low potential. Then we will take it as minus V. This convention we will be using in R circuit, and using voltage for battery we will use this, and for resistance we will use this. Okay, but it's not compulsory. You can use another convention also, opposite of it also. Okay. Any problem here? You can ask. Any problem from here? One question you might be thinking, sir, why are you taking this here negative minus IR? Not necessary, but I tell you. You know, earlier also I have tell you this is VA and this is VB. Current is flowing from here. That means VA is greater than VB. We can say this potential is greater than this potential. So when we are moving in this direction, how we are moving? We are moving from high potential to low potential. High potential to low potential. See here. When we are moving from high potential to low potential, we are taking minus V. Similarly, high potential to low potential, we are taking minus sign. And when we are moving this direction, it is low potential and it is high potential, we have taken positive sign. So to have no confusion, we are using this convention. Any problem in this convention, you can ask. Any problem, anyone, you can ask. Okay. Let me take now one example, small example. One example. Take, I give you one circuit diagram like this. Okay. Like this. It is having a value of like this. Now let me take a symbol here. Okay, it is a 10 volt. It is having 5 volt. Value of resistance is 2 ohm. It is also 2 ohm, 2 ohm, 2 ohm, and 2 ohm. Like this. We have to find the current in the circuit. How much current is flowing through it, and how much current is flowing through. We have to find this. Okay, in each branch, how much current? Let us say it is I1, it is I2. Okay, we have to find I1, what will be I1 and what will be I2. Okay, what we will do, how to proceed? Let us take example. Now, for this type of question, first of all, if current is given, then okay. Not given, then we have to assume I1 and I2. Now, let us suppose I1 current flows from here, and we know in this connection, this type of series connection, okay, current is same. Okay, current will be same here, like this, current will be same. So, if current is same, at this point, what will happen? I2 is current coming here. I2, you can see, I2 is coming from this side. What will happen? They will get adds up here. How? By KCL. We know by Kirchhoff's current law, at a junction, incoming current will be equal to outgoing current, and the outgoing current is I1 plus I2. Okay. Now, at this point, I1 plus I2 comes, and the corresponding current will go to the corresponding source. So I1 will go this side at this point, and I2 will go this point. Okay, and they will terminate at the negative or low potential of their source. Okay, now current distribution we have done. Now what we have to do? We have to take loop equation. Now let us assume this is the loop equation. We take loop 1 and we take loop 2 here. Okay, loop direction, no worry, you can take in any direction, but usually we take in a direction of current. You can see in direction of current, the direction of current, but it's not any convention. You can use any direction of that loop. Okay, now I am writing equation in loop 1. You can see loop 1 clearly. I am starting from here, any point from here. Okay, moving this direction. I tell you, moving in direction of current. What we will write? Minus 2 into I1. Okay, here you can tell like this, I1, and here 2 resistance. What you will take? Minus 2 into I1 here. Now at this point we will go down. What will happen? Again along the direction of current, you can see current in the direction of current, and we are moving this direction only. Then again minus sign. We will write I1 plus I2 into 2 ohm. We reached here. Now we will go here. Now in this cell, what we are doing? We are moving from negative low potential to high potential. That means positive sign, 10 volt, and we reached here. Initial starting point equal to 0. Okay. By using this technique, we have written the equation. Now loop 2. See loop 2. What will happen in loop 2? We are starting. We have to take in this direction. Okay. Now let us start from here. From here. Now from here we see we are moving from low potential to high potential of a cell. That means positive plus 5. Okay. from here we are moving in direction of current, that means minus of I2 into 2. This direction, again direction of current, that means minus of I1 plus I2 into 2. From here you can see we are moving in direction of, from here we can move moving in direction of current, that means minus of I2 into 2. Okay, we reached here. This is the starting point, so equal to 0. We can arrange it. What we will get? We will get minus 4i1. We can break this bracket also. Then we can write it clearly like this: minus of 6i1 minus of 2i2 is equal to minus 10. Sign, remove the sign. We can write like this: take 2 common. 3i1 plus 2i2 is equal to 5. One equation you can get from here. Similarly, second equation from here, and you can solve it. Okay, solving 1 and 2 equation, you will get value of I1 and I2. Okay, any problem here? And one more thing, you can write one more equation. Sometimes it will be needed for you. You can write this equation also. How? You can write this equation also. I show you. One more equation you can write like this from here. You can write one more equation like this. How? You can write one more equation like this. You can start from here, go here, and move there and come to this point. Okay, you can write this equation also, this big loop. Okay, any problem to anyone, you can ask here. Okay, then if you will get comfortable with this writing equation, then I will tell you one shortcut, one short trick how to write this equation very easily in one step only. That I will tell when you will get a perfect in this writing this equation. Then I will tell you the shortcut. Okay. Now we are coming to grouping of a system. We will take some more example of Kirchhoff's law, second law also. First, let us see them. The grouping of a system. I think you must have studied the grouping of a system in class 10th also. So I will not be dealing in very much detail. So I will be dealing with the part which I asked in exam. So let me take one example, one circuit. Let us take, there we are having 3 resistors like this: R1, R2, and R3, and is connected to a cell V. Okay, it will supply current I. You know one important thing in a series resistance, series combination, what is happening? I, that is current, is always same. Remember, current, that means current I will flow here, I will flow here, I will flow without any decrease. Okay. Now, if current is flowing here, what will happen? We will have different potential differences. How? It will be I into R1, it will be I into R2, it will be I into R3, and it will be different. That means we will say current is same, but potential difference is different. They are different. You can see V1, V2, they are different. And after solving this, we can write like this: V is equal to this, V is equal to this plus this plus this, and we will solve it, and we will get what result? We can write like V is equal to IR1 plus IR2 plus IR3 like this. Okay, and we will get the value like this: R equivalent is equal to R1 plus R2 plus R3. Okay, I'm not going to detail. Okay, you must remember this is opposite to capacitor. You must have seen capacitor when it was in series resistance, series capacitance, it was this formula. You should remember this. Okay, for series capacitor this was the formula, and for series resistor this is the formula. One important thing, if remember one short trick. What? if we are having R resistance n times, okay, their R equivalent will be n into R. Okay, should remember this. Okay, I think you will having no problem here because these are just repetition part. Second, parallel combination of resistors. Okay, let us suppose we are having some resistance value like this. You should remember this circuit. Okay, and we have connected it to a cell V. We can see here what is the important point to remember here. It is having R1, R2 and R3. Okay, voltage across this resistor is V, across this resistor is V, and across this resistor is V. That is, we can say potential difference is constant, but the current supplied from here I will be goes here I1, goes here I2, and goes here I3. That means current will be different. We can say I will be different and potential difference are same. So we have seen I is equal to I1 plus I2 plus I3, and we will solve using this formula. And what we get? We get 1 by R equivalent is equal to what? 1 by R1 plus 1 by R2 plus 1 by R3, and so on. This type of formula we get. Okay, I am not going to the derivation part, not necessary. It is similar to series combination of capacitor. Series combination of, okay, few shortcut you should remember to become a have fast calculation. What you should remember? You should remember if we are having two resistors like this, R1 and R2 in parallel, then their equivalent is equal to product and by sum of both of them. Okay, first one. Second, if we are having this value resistors and so on, R, and so on. Okay, R, then their R equivalent is equal to R by N. Okay, should remember this value. Any problem till here? Any problem till here? Okay, let us move further then. Let me take one example then. Then we will take some questions, good questions also. Let me take one example. You know, first of all, you must have been knowing that. Let me take one example, then I will see. Let me take one example. We are having a circuit like this. This is switch, and it is connected here ammeter, and we are connecting here voltmeter. Okay, and we have, it is 2 ohm and this 2 ohm, and it is connected here to a 10 volt battery. Find, question is that find ratio of current when K is open and when K is closed. Okay, can you try this? Try this. We will take good question. There are many good questions here in today's session, but please try this question. This is also an important question for NEET exam. Please try this question. This is a circuit part. K is switch, voltmeter V is given. Okay. When open, 5 ampere. Okay, when it is open, you will be having 5 ampere. How can you say 5 ampere? When K is open, you see when K is, I think you should check once. If K is open, K is not connected here, That means it is working now. It is working, both are working. Then what we will get? I open, current in open condition. What we will get? Total voltage 10 and total resistance will be 4. That means it will be 2.5. Like this, you can see. In second case, you should close. Okay. When you it is telling that what will the ratio of current when K is open. For K open, this open, both are effective, though both are working. When both are working, we will get I open is equal to total voltage by total resistance. Okay. Now, when K is closed, second part, what we will get? K will be closed. Then whole of the 2 ohm will be useless, because their equivalent will be 0. Why? Because we know when we have connected here, that resistance will be 0. And if you will take value of their equivalent, one is 0 and one is 2 ohm, you will get their equivalent will be always equal to 0. That's why we will have to remove this second case. This 2 ohm will be removed. Now I closed. In closed condition, I will be total value of voltage by total current, total value of voltage by total resistance. Resistance value will be 2 only. We will get 5. Now ratio of I open by I closed, it will be 2.5 by 5, and your answer will be, you can solve from here. Any problem? I think so explain again. Okay, let me tell you once again what I told, you can see what I told here. I told here when K is open, okay, K is open, that means you can redraw the circuit like this. 2 ohm here, and here it is connected with 10 volt. Okay, voltmeter you can connect or not connect, that depends upon you. Okay, now when we are connecting like this, you can see here it is you can see here when K is open, that means it is open like this. Okay, it means this is useless because K is open, so current will not flow through it. Okay, only current flow will flow through it. It will be effective here because it is open. Current will flow through this path. So 2 ohm will be effective and this will also be effective. So for this case, R equivalent will be 4. Series addition of both of them, series addition. That means current will be, I open will be total voltage by total current. And if it is closed, what will happen? Let me take one example. When K is closed, if K is closed, you have to see here, if K is closed, what will happen? You can see what will happen if K is closed. It is closed, you see, it is closed here. If you will close, then what will happen? You can see here, what will happen? The current flowing through it will come here. It will have 2 paths, one path here, one path here. This path is having resistance equal to 0 and this resistance is equal to 2 ohm. You see, if you will find the equivalent of both of them, one is 0 and one is 2 ohm, and both are in parallel, you find equivalent of both of them. R equivalent of R1 into R2, product of both of them, 0 into 2 by 0 plus 2. What you will get? You will get 0. That means equivalent, the equivalent of this will be equal to 0. That means this 2 ohm resistance will be useless. Now, if K is closed, only effective will be 2 only. That means here R equivalent will be 2 only. So we will write I of closed will be how much? 10 by 2. And you will get the answer, and you will take the ratio of both of them and you will get the answer. Clear or not clear? Okay. Let's move further. I give you one example. Okay, one question for you. We are having lots of questions today. We will discuss it. Okay, just creating your basic, clearing your basic so that you can attempt those type of questions also. Okay, now let me take one example. I take one example like this. Suppose I'm having here like this, here like this. Okay. Like this. Let me take example like this. Like this. Suppose we are having here voltage V is equal to 10 volt, and here it is given voltage is equal to 2 volt. One more. Let me take one more. I reduce this part because I think this will not ask in your exam. These are for JE people. JE because they will this type of question is asked. I make you simple like this. Put here plus minus 1 volt, and one more here like this. One more here like this. I put here minus plus. It is 1 volt. 1 volt. It is 2 ohm. It is 2 ohm. It is 2 ohm. 2 ohm. 2 ohm like this. Now you have to find current through here I1, here I2, here I3, here I4, and here I5. You have to find I1, I2, I3, I4, I5. Very good question. You have to try. Try once, and it is given here. It is earth here. Earthing is provided here. It is given earthing is provided here. You should do. Try. All of you try. Any answer? Try. All of you try. Try this question. All of you try this question. 10-second time. Try this question. Any answer? Any answer came? Okay. Let me solve. Let me show you. These are second variety of questions, so don't worry that you are not able to solve it, because these are second variety. I have not taken similar type of question. Now this 10 volt, you know, all the branches, this branch, all will have same potential because they are in parallel connection. One end are connected to 10 volt and other end are connected to 0 volt. That means we can say both the branch, all the branches, 5 branches are in parallel connection. We can say it is 10 volt. That means here also 10 volt, here also 10 volt, here also 10 volt. At every point it is 10 volt. Okay. It is 0 volt here. We can say it is 0 volt here. It is 0 volt here, 0 volt here. All points 0 volt. Okay. Now we have to write individual current. Okay. Now let us take this for I1. This is I1. We can write like this. I1. What is I1? We know by Ohm's law. We know. We know. Look here. Let us suppose this point is A and this is B. You can say like this. VA minus VB is equal to I. What is I? You can see it is I1 into R. You can see here AB. VA minus VB is equal to I1 into R. You can write like this. VA is 10. VB is 0 is equal to I1 into R is 2. You can write like this. I1 will be 5 ampere. You got the I1. Now for the next circuit, similarly you can do for here also. I2 will be also 5. Okay. I am taking here. Okay. I am taking here. Suppose it D and it is E. Okay. I am taking here. You will take here B, CD. It will be C and it will be, let us take C and this as C dash. You will take this branch, you will get 5 volt. Okay, I am taking here D to E. I can write like this: VD minus VE. But you should see here also. You should see here also. VD and VE. There is one potential here, one battery also, and this battery plus sign is along the positive side, and the negative terminal is along the low potential. So this will be also equal to, we write like this. This for this battery, we will write like this. You can write right here like this: minus 2 volt. If you are getting confused, then tell me. I will show you another method. Okay, is equal to I3 into 2. Any confusion for here, you can ask. I will show you another method. If you will get confused here, to write, I will show you one more method. If you will get confused, any confusion here. Similarly, for this branch also, you can write D. Let us suppose F and G. I am writing for FG, for FG branch. You see, for FG branch, I can write like this also. You see, how I can write like this? You see, I am writing for here. You can see here it is 10 volt. I can write like this: VF minus VG is equal to VF minus VG is equal to, I can write like this: VF minus VG, and there is one also potential, and its potential plus sign is along the high voltage and minus sign is along the low voltage. So it will be written here also: minus 1 volt is equal to, what we can write, I1, that means current is I4 into 2 ohm. Okay, you can solve here. How? You can solve here. VD is equal to 10 volt, V is equal to 0 volt, it is to minus 2, it is 2I3. You can get I3 from here. Okay, similarly 10 volt minus 0 volt minus 1 volt is equal to 2I4. You can get I4 from here. Okay, now in fifth branch, you can see here, this branch, you can see here, we can write like this. You can see I am writing direct like this. You can okay, not directly, FGH, and let us suppose GH, I say PQ branch. For PQ branch, I can write VP minus VQ. Now you see, the negative terminal is along the positive side and the positive terminal is along the negative side. Then plus 1 volt is equal to, how we will write, I5 into 2. Okay, put this 10 volt, 0 volt, and you will get the answer of I5 also. Any problem here? You can ask any problem. Then I will also show you one more method. Any problem to anyone? Okay. Similarly, I show you one more method. Because I think it will be very much useful for you if you will go through a good circuit. Then suppose you have to apply Kirchhoff's law. Suppose you are having 2 points A and B. You have to write Kirchhoff's law between A and B. Okay, Kirchhoff's, you have to write Kirchhoff's second law. Okay, Kirchhoff's second law between 2 points, that is A and B. Okay, and you have to write like this: VA minus VB. Okay, how you will do? You just have to write Kirchhoff's law starting from B, reach A. That's only. How you will do? You will do start writing Kirchhoff's law, second law. We call it as Kirchhoff's voltage law, KVL. Okay, Kirchhoff's voltage law, KVL, from B and end up at A. Start from B and end up at A. I show you one example using this. Why I have written this? Okay, I show you one example so that you will get clear. I show you this. This will very much useful for you when you will solve a good question. Now, let me take one example. I take this example, VDE. You see, VDE. Okay, what we have to do? We have to start from E, low potential. Okay, start from low potential like this, VAB, then start from B and reach A. So start from E and reach D. Okay, start from E. Remember, starting from E. Okay, now we write like this. How we write like this? You see, we write VD minus VE is equal to, start from E. You start from E here. Okay, starting from here. Okay, going this side, this way, this way, this way. You see, we are moving along the cell, and you see, cell is voltage is increasing from negative to potential. It is increasing. So we will take here plus 2 volt. Okay, plus 2 volt. Now we are moving along the current direction is this, and we are moving opposite to direction of current. So we will take it like this, plus 2 of I3. Okay, and this will be the value of your. Okay, you see this equation and this equation we have written here. These both are same equation. You see. Okay, you see here this equation. Let us suppose this equation is star and this equation is second star. You see both equations are same. Okay, I use this technique of Kirchhoff's voltage law for this point also, for PQ also. You can write like this for a PQ. You see, I'm writing here last equation, last for PQ, P minus Q. It means start from Q and reach at P. Okay, start from Q, starting from Q. Okay, moving this direction. We see that we are moving in from high potential to low potential. High potential to low potential. That means high to low. That means we have to write minus of 1, minus of 1. Now, opposite to direction of current. Current is flowing in this direction. We are moving opposite direction of current. By our sign convention, it will be positive. Okay, we write positive and we write 2I5. You see here this equation. Okay, and you see this equation also here. Okay, these both are same equation. You see this equation and this equation. These both are same. Okay, any problem to anyone, or I should move further? Any problem? Write clearly problem, no problem. Here, all of you, please write comment. Please be interactive. Okay. So remember, this will be using frequently. Let us take some questions. Now, I give you 30-second time. You try this question. This is a good question. You should try. I give you 30-second time. Try this question. All of you try this question. Any answer came, then you can say me the answer, your answer. Any answer came there. Try this. I give you 30-second time. Try this question, 30-second time. Any answer? Any answer? Any answer? Okay, let us see then. Let us see. Okay, no worry. Let us see how to solve it. Let us see. Let us see how to solve it. Now, when we are seeing this equation, how we will solve it? Let us see. Let us. You can see one thing. You can see here from A to B, it is a symmetrical circuit. You can see left part and right part both are symmetrical. Okay, so if you get symmetrical circuit, then you should try to use the symmetry relation, because it will very much, it will save your time always. So when we are seeing that it is a symmetrical circuit, then we will solve the one of the part, left part or right part, and we will use for both of it. You can see here from A, if we are starting from A, you can see here from A and B, you can see it is 2R, both in series 2R. This 2R and this R are in parallel. I can write like this. From A, we are having 2R resistance, and this 2R is in parallel to R. Okay, this 2 are in parallel to R, reached here. Now again R, from here again R, and this R and R, 2R. Okay, again parallel. We reached here point B. Okay, you can find this. What we will get? We will get 2R and R parallel, R and 2R parallel. So how to solve it? We know 2 in parallel. We can write like this: R into 2R by 3R. Solve this. We will get 2R by 3. 2R by 3 here for here, and same for here. So we will multiply by 2 here. We will get 4R by 3. 4R by 3 resistance for this part. You see, we can when we are using the symmetry, we can say what we are having. We are having 4R by 3, one part. Second part also 4R by 3. Second part also this part 4R by 3. So this part also 4R by 3. And in between there is one R resistance parallel between them. So we will write one resistance R parallel between them, and here is A and here is B. You can solve it. Both are in parallel, same. You can see 4R by 3 and 4R by 3 in parallel. We can write like this: 4R by 3 into 2. You will get parallel equation value. 2 resistance in parallel. We know it is R by N. Okay. We are right, 4R by 3 by 2. Okay. Now it is parallel to R. You can see this one R. What we will get? We will solve it like this: 4R by 6 into R by 4R by 6 plus R. Solve this, then you will get the answer. This much only. Any problem to anyone? Any problem to anyone? Any problem getting the question, or I should repeat? Any problem? Please be interactive. Interact. Please interact. Repeat. Okay. I repeat once more. What I have told you? I told you this. If in this type of circuit, you have to use the symmetry condition. Okay. So what is symmetry condition? You are seeing that this part of the circuit and this part of the circuit, both are same. So we will solve equivalent of this part only, and we will equate that this will be equal to this part also. Okay, that's concept we have used. We have find the equivalent of this. How we have done? We have taken R and R in parallel, R in series, and one R in parallel drawn here. You see, R and R in series became 2R, and one R in parallel, that became 2. That becomes this part. Okay, meeting here. Now from here, 2 resistance R and R, 2R and 1 R in parallel, and we reached here point B. You see here 2 resistance was here, that was 2R, 1 R here, and we reached the point B. This is the equivalent of left part or right part, one of the part. We solved it. We got here 4R by 3. If all things are correct, then we will get here 4R by 3. Now we know this is 4R by 3. This also will be 4R by 3, and in between them 1 R also be present, and will and both of three of them will be in parallel. I drawn here, you see 4r by 3, 4r by 3 and 1r. All three are in parallel. We solved both of them, all of them. What we did, this 4r by 3 and this 4r by 3, they are same and parallel, and we know for any resistance r in parallel, and if both are same, how we write a shortcut, r by n, number of times they are repeating. So for 4r by 3, we see it is repeating 2 times, 4r by 3, 4r by 3. What we have written here, 4r by 3, this is the resistance value, and we have divided by 2. You see 4r by 3 divided by 2, and this is parallel with r. You see here, and we have applied here the value of their grouping. We have seen here 4r by 6, and this applied here, and you will get the answer. Any problem in understanding this, or you have not got till now? Any problem? Got it? Okay. All of you, please interact. Now, let us take some simple example then, and it will be more beneficial and more concept clearing for you. So take us now. We take us some simple example. Solve this. I give you 15-second time. All of you try this question. 15-second time. Take this time and give the answer. Please, all of you should try. Now we take some simple question only. Any answer? Any answer? Any answer? Any answer? Any answer? Any answer? Okay, no worry. Let's see. Let us see. We have to find the value of this current. If we have to find the value of this current, first of all, what we have to do? Okay, let us see. What we have to do? We have to find the resistance. You will see here. We have to find the value of resistance. How we will proceed? Whenever you get this question, what you will do? You will take the current is entering from here. You will take resistance. Listen, how much resistance is here? Equivalent resistance. If you will find the equivalent resistance, current is given, a current you have to find, and we know the voltage value. If we divide this voltage value with resistance, we will get the answer of value of current. So what we will do? We always take the value of equivalent resistance and we divide it by voltage. How to take equivalent? We know these two are in series. That means 12. This 12 and this 3 in parallel. What we will do? Parallel 3 into 12 by 15. We will get here 5 value of R equivalent. Now, when we are talking about current, I will be V by R. V for 4.8 and R is 12 by into 4, 5. We will get here 4 and I think 2 ampere current. Good. Okay. Anyone? Any problem? Okay. Let us move further then. Solve it. Solve this question. I give you 30-second time to solve this question. Solve this. Solve this question. Solve this question, all of you. Solve this. This is a good question. Solve this. Okay. Okay, no worry, no worry, no worry. Let us see how to solve it. Let us see. Now let us see. We have to find equivalent between A and D. A point is here and D point is here. You can see now when we are how we have to proceed. First of all, either you start from A and reach to point D. You see how many the resistance are, how they are appearing. They are appearing in series or they are appearing parallel or they are not appearing, they are useless. You have to decide this also. Now, when we are moving from here, you see this is in the series form. After this, from here, we have two branches. You see here, that means in parallel. From here, we draw like this. A, we moved, we are having 10 ohm resistance. Now, at this point, we are having two resistance here, 10 and 10. From here, this point, we are having two resistance. One is 10 and another is 10. Okay, this one. After this, at this point, we came here. What we are seeing that at this point, we are having again two resistors, 10 and 10. But my dear friends, you see here, for this 10 ohm resistance, the other terminal is useless because it is not connected from A to D anywhere. Okay, so this resistance is useless, no value. We have to not count in the equivalent resistance. And similarly here, it is having one terminal, but we are not connected another terminal to any of the point between A to D. So this will be also useless. So what we see, 10 ohm, 10 ohm, 10 ohm parallel. Again from here, it is useless. So we will say 10 ohm in parallel series. This 10 ohm and 10 ohm in series. That means we can say like this, 20 ohm, 20 ohm. Okay, they are in parallel. They are in parallel. They are meeting here. They are meeting here. You can see here, 20, 10, 10, 20, 10, 10, 20. Meeting here and again 10 ohm resistance and reach the point D. Again 10 ohm resistance and reach the point D here. You find the equivalent and you will get the answer. What you will get? 20, 20 in parallel equivalent to 10, 10, 10, 10 series. What you will get? You will get 30 ohm. 30 ohm will be answer. Any problem? Anyone? Any problem? Any problem to anyone? Okay. Okay, everyone should interact. Everyone should interact. This session should be interactive. Okay. Now, let us see this question. Try this. I give you 30-second time. Try this question. You should try whenever unless you don't try your question, your concept will not build. So you should try first. Try first. Write in a copy. Solve this. Give me the answer. Give me your answer fastly. Give me your answer fastly. Any answer? Any answer? Any answer? Any answer? Any answer? Okay, let us see. Nobody. See, you should remember this is 10 ohm resistance. That means here it will be 10 ohm. You can say here 0 volt. So that potential difference is 10 volt. Okay, 10 volt. Here also 10 volt. Here also 10 volt. Because in between them no resistance are present. So no drop of voltage. Okay, here also 0 volt. Here also 0 volt. Now this is a similar type of question which we have studied earlier also. Now this is ammeter connected here. How we write this point? 10 volt. This point 0 volt. We write like this. Current through here. This will be I is equal to potential difference. What will be 10 minus 0 by equivalent resistance will be 5. We will get here 2 ohm, 2 ampere. And if current is asked through this branch, what we will say? We will say I will be equal to 10 ohm minus 0 volt. That means we will say 10 minus 0 by resistance is 4. What we will get here? We will get here 2 point, I think it will be 2.25 like this. Now, if it is said find the total current, what will flow from here? We will say 2 plus 2.25. Answer will be 4.25. Okay, but in this question answer was this, so answer will 2 ohm, 2 ampere. But we can get this for total current, this for this branch current, and this is for the given ammeter reading. Okay, any problem? Any problem? Any problem? Any problem to anyone? Okay. Everyone should interact. Everyone. I always wait for response of everyone. Now try this question. All of you should try this question. Try this question, all of you. Try this question, all of you. Try this question, all of you. Try this question. Any answer? Any answer? Any answer? You know one thing, ammeter reads current and voltmeter reads voltage. Okay? Find this. Any answer? Okay. Nobody. Let us see. Don't worry. Let us see. Don't be worried. Don't bother. Okay? We will clear it now. Let us see. We know. Let us suppose the current I is flowing through here. I will go here. I will go here. Now we will have two paths. Okay. We are having two paths. One is I going here. Okay. Now, what will happen? There will be two paths. One is here and one is here. You see here. Here you can see the resistance of voltmeter is also given. You see here. Okay. What we'll say? We will assume from here I is coming here and I1 will go here. Okay. Then how much current will go through this voltmeter? We'll say I minus I1. Okay. Any problem to anyone? What will happen? I1 will go here, and from here what will current come? I minus I1. You see here at this junction, I1 here, I minus I1 here, both adds up here, and you will get I here and I will flow here. This is the current distribution we have done here. Okay. Now we have to find the value of this value, I minus I1. Okay. How we will write this? One thing we can do, we can write one Kirchhoff's equation. Okay. We should write one Kirchhoff's equation. Let me write one Kirchhoff's equation here. Let me write one Kirchhoff's equation here. Let me write. Write one Kirchhoff's equation this loop. Let me take one for loop 1. For loop 1. What I will do? I will write this loop 1 equation. What I will do this from here, starting from here, I am moving from low potential to high potential, from low potential to low to high potential. I will take it as plus 6 from low potential to high potential. Now from here, yes, we can see here, you see here, from here you can see here, it is 400 ohm. So moving in this direction of current, this direction, current direction, we will take it as minus of 40 ohm into I By our convention, we know the moving direction of current, it will be minus sign. Now, from here, we are moving here also. It is 60 ohm. Again, direction of current, we will say minus of 60 into I1. Gone here, no resistance, we reached here. This much equal to 0. We can rearrange it and give that it will come to be. I take 2 common. I can write like this. 3. I can write like this. 3 is equal to 20I minus 30I1. I minus not 5 plus 30. Okay. First equation got. Now for second equation, what I should write? I will write KVL equation in this loop. In this loop. Loop 2. Let us take, say example, loop 2. How we will write? Starting from here. I am moving direction of current. You see, it is 40 ohm. Moving direction of current. I will say like this: minus of 40 ohm into current is I minus I1. You see, current is I minus I1 flowing through it. Coming here, no resistance from here. Now here. In this direction, we are moving opposite direction of current. You see here, I1 is moving in this direction and we are moving in opposite direction. We will say plus I1 into 60 ohm equal to 0. Came reach the initial point. You can rearrange it. What you will get? You will get here minus of you can take divide it by take 10 common. You will get 6I is equal to 4I minus 4I1. This one. Take common here. 4 will go here. It will be 10I1 is equal to 4I. That means 5I1 is equal to 2I. Take this example, this equation second, this equation first. Okay, solve these two equations. You will get the value of I minus I1. Okay, or you will get the value of I1. Okay, you will take the value of voltage from here. This current into this voltage, you will get the value of voltage, or you will take product of I1 into 60 because both of them will have same voltage and ammeter will read the voltage across it only. So you can either you multiply I1 into 60 or you multiply I minus I1 into 40. You will get the both the same answer. Okay. Any problem? Any problem understanding this? Any problem? Anyone? Any problem? Okay. All of you, any problem? Okay. We are having lots of questions, good questions set also here, but I'm ending the session here only. Okay. You first revise all this concept. We'll take some good questions also in our tomorrow class. We will having a good question set of questions also. I will discussing. Okay. So please and please, I personally request you all so that it will be a beneficial session if you will revise and come, because we will give it with a good circuit tomorrow also and good number of questions.